So hope you have enjoyed or celebrated the Deepavali festival. So dear student, in the last class itself we have completed the first chapter called Some Basic Concept of Chemistry. Today I am going to start the very next chapter that is structure of atom. Right? Structure of atom. So let me introduce this chapter first, and then later we will see what are the things are there in this chapter. So, in structure of atom chapter 1, we going to see the detailed idea about the atom, right? So, after having a knowledge about this chapter, we are going to learn. So, what is again once again what is a molecule, what is an element, what is atom, and in atom what are the fundamental particles are present, who discovered those particles, right? So everything, and then models of atom and discovery of atom, and then Rutherford X-ray scattering. So that means with the help of Rutherford X-ray scattering, one we can conclude that in an atom there will be a nucleus which is very rigid, that means hard, and around that nucleus there will be a revolving of electron, right? And later we will see line spectrum of hydrogen, photoelectric effect, right? So these things are, and then isoelectric elements, isotopes, isobars. That means we going to see in this particular chapter all about the atoms. So what all it consists of, what is its history, who has discovered electron, proton, neutron, particular names are there. Different scientists have discovered these electron, proton, and the neutron, and their charges also, right? So atom is nothing but, dear student, you already know. So atom is nothing but a very smallest particle, that means which will not further undergo into the division. I have already discussed these concepts in our basic classes. So if you know, or if you followed that classes, means this chapter will be very easy for you. And again, this chapter we will start with the atom itself. So okay, already I think you might have the what definition and all about the atom. So I don't want to give about detail, I mean definition about the atom. So just I can say that the atom is a very smallest particle which will not further go into other division, right? So now if I say, if it is an atom, then definitely there will be a what this will be a very smallest particle when we can say. If I what if I apply some force or a external energy, then definitely it will not further undergo into the division. If it is not going into the division, then one we can decide that the atom is a very smallest particle, right? So coming to some more basic about the atom is nothing but, atom is consists of not only electron, not only proton, as well as a chargeless fundamental particle, that is neutrons. So the combination of these all three will make a smallest thing, that is nothing but the pocket of energy, one we can say, that is a atom, right? So now atom is a smallest particle we came to know. And if I show you this just a general diagram of about the atom, then definitely the electron will be revolving around it always. So now, and the proton means already you know there will be a positively charged species electron. And student, I repeat once again the basic classes, that means electron always carry, remember this point, electron always carry a negative charge, and proton and neutrons are present in the nucleus. That means proton and neutron are present in the nucleus, that means center of the nucleus. So here neutron is nothing but neutral, no charge, right? So this fundamental particle has no charge, but the one more fundamental particle which is present in our nucleus, that is proton. That means this proton carries a positive charge, right? So here proton, that means in chemistry always if I say proton is nothing but what, the thing is nothing but a positively charged species, one we can say, and the electron is always carries negative charge, and negative charge will not be different from electron to electron. The charge will be same, its mass will be same, right? It will not change. But according to till now what we considering all the theories, all the concepts, all the theorems, everything, whatever we have till date. So what they suggest is, the energy or else the size or else the shape may differ, but the charge will not be different from one electron to other electron or one positive charge to other positive charge. Charge and its mass will be always stationary, one we can say, right? So with this we will start with the our syllabus, right? So now here first thing is here in this chapter is atom only. So already we know what is atom and all, and then the next is molecule, right? So again in first chapter only we have discussed about the molecule and all. Then also if you want you can have it once more. So molecule is nothing but a substance formed by atoms or molecules. I mean, atoms are the same atom combination or different atom combination may lead to the formation of what? Molecule. But molecule is, if I write a single element, then it will not called as a molecule, right? When we should call this as a molecule means whenever two or more element combines, right? Element means single part. So if these things, that means element of same or different case, if they combine, then give a thing or a substance or a compound, that is nothing but the molecule. That means combination, there should be a combination of chemicals. If they have the combination of two or more elements, then definitely one we going to get what, that is molecule. In the last class, I mean sorry, in the last chapter also we have discussed clearly about the molecule, right? You just to go through it and revise it. So next is nucleons, right? So the next atom, molecule, and then nucleons, very important. So these are the new concepts for you. So these things belongs to particularly this chapter, nucleons. So nucleons, the particle present in the nucleus, right? The particles present in the nucleus, the particles present in the nucleus, that means in nucleus what we all have, we have, just now I have discussed proton plus neutrons. So that means the particles present in the nucleus is nothing but what? Nucleons. So these are very basic terms you should know, right? So nucleon is nothing but what are the particles present in our what nucleus of any element, not only the particular chlorine or a hydrogen, but in general, every particle in its nucleus there must be having proton as well as the neutron. So proton and neutron together is nothing but what? Nucleons, right? So just now I have discussed about this. That means this is a nucleus, and in this nucleus what we have? Proton as well as neutrons. So proton and neutron together is called what? Nucleons, right? So proton as well as the neutron is nothing but what? Nucleons, right? Understood? So now next is isotopes. Next concept is isotopes. In the beginning of this chapter, we have some definitions, right? And then later we will go with the concepts. So now isotopes. So this concept is very common in chemistry as well as in the physics, right? These are the species. These are the species or chemical species from the chemistry. These are the species having same atomic number, having same atomic number they must be having same atomic number and different mass and different mass, same atomic number. Condition is they must and should have same atomic number and differ different mass number. Mass number should be different, right? But the atomic number should be same. Different mass number is called isotopes, right? Very simple. So if I write the example, then you can very easily understand this. So H11 comma H12 comma H13, right? See here, these are the isotopic form of hydrogen. That means hydrogen is same here, but they are showing. See here, I will show you A Z. Z is nothing but what? Atomic number, right? In the last chapter, A is nothing but what? Mass number. So what is the condition? A is nothing but, I will write here, mass number, right? Z is nothing but what? Atomic number. So now you compare these. See, first you see the in this particular example, you see just a atomic number. Atomic number is what? Same. That means these are the species having same atomic number. See here, atomic number is same in all the three cases. Here, same atomic number. Okay, understood? Now, and different mass number. So that means mass number will be always at the top. So that means, see here, here the mass number is 1, here 2, here the mass is 3. So that means we have different mass number. Such a condition or such a species are called what? Isotopes. So that means these are the chemical species having same atomic number, but they should have a different mass number. So if I say this one we call protium, deuterium and tritium. So among these three, you remember one point. So I repeat, protium, deuterium, tritium, and among these three, tritium is isotope. I mean, it is a type of isotope which is radioactive. Once this has been asked in your competitive examination, among isotopes of hydrogen, which one is radioactive isotope? So that means your answer should be tritium. It is a radioactive element. If you go through your book, definitely you will be having this point, right? So now isotope, you remember this. Why? Because it is very important in some other concepts, it will come directly. That means these are the isotopic forms. That means if you know the definition, then definitely isotope means you come to know what is isotope, right? So now see here, these are the species having same atomic number but differ in their mass. Then such chemical species are called as isotopes, right? So now the next thing is isobars, right? Isotopes, and these are very confusing, so that's why we can expect one 1 mark question from isotope, isobars and isotones, right? So next we will go see isobars. So bars means what? These are the species. These are the species having same mass number, just opposite of isotope, mass number, but different atomic number, right? So now you just see, just opposite of isotopes. So here these are the species having same mass but different atomic number, mass number you can say, same mass number but differ. If they differ in the atomic number, then definitely those are called as what? Isobars. Example, if you see, definitely one you can come to know what is C14 and N714. So this is also a carbon isotope. So that means already I have said you, carbon can show 3 isotopic forms: C12, C13, C14. So now here see clearly, when you can see, upper digit will be always indicates mass number and the lower digit will be always indicate atomic number. So here atomic number is different as per the definition. Atomic number is different. Here atomic number is 6 and here the atomic number is 7. But what about the mass number? Mass number is same. If such chemical species are called as what? Isobars. These are very easy to understand, but all the three, that means isotopes, isobars and isotones, comes together, then definitely some difficulties will come. So with this we will stop here itself, and in the tomorrow's class we will discuss the next point of it, right? Thank you.